All right, now I think you people are totally fine. Okay, so last time we learned about the mass. Okay, and we also learned about the derived units. All right.
Uh, Excuse me, sir. 1 minute, sir.
Yes, sir. Okay, all right, sir.
Who is Free Fire here? Please, can you change your name?
Sorry, sir. Oh yeah. Please, will you just Free Fire? Which Free Fire? Sarina Kafle. Please change your name. Okay, write your name there. Don't write free. There is not Sarina Kafle. Who is that? Free Fire. Sneha. Who is that Free Fire? Please write your original name. Okay. Please write your name there. All right. Otherwise, you may be sent out from the classroom. Okay. Please make sure about it. Right. Write your real name there. Who is that Free Fire? Fire. Are you going to burn someone? Free Fire. In free of cost. That's it. There is written Free Fire.
Free Fire, I will be keeping you in waiting room, okay? After you have changed your name, I will accept you.
Yeah, all right. That is the punishment. Okay, so please do not ever write your misleading name. Okay, write your real original name. All right.
And all of
Now
you,
let
please
me.
enable your video also.
Yeah, and you will have to enable your video also. Okay. I need to see your face, right? I need to see your beautiful faces. Okay. That's great. All right. Wonderful. Welcome. Now the numbers increasing. Okay, increasing. That's great. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right. Iksha Bazagai, come little closer to the camera. Okay. You are very far from the camera. Come little closer. Iksha Bazagai. It feels you are. I'm in Nepal and you appear like you are in India. Very far. Come little closer. Okay. Yes. Welcome, Kelvin. Okay. That's great. Okay. Praiska, welcome. Supreme, welcome. All right. Who is that Prozwal? I cannot see your face properly. Oh yes, you are Nirvik, are you? Your name is not Prozo. You appear Prozo. What is that? Anyway, I like your haircut. That's wonderful. Okay, students, I guess we'll have to start our course, shall we? All right, now let me count the number for the last time. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. All right, Yuzana Thapa, welcome. Where is Yuzana Thapa? Oh yes, she's coming. All right. Okay, now without any further delay, let's get started. Okay, let's begin our battle, shall we? Okay. Now, so last time we learned about mass, isn't it? All right, we learned about mass. So let me repeat for the last time again. So actually, mass is okay. Yes, fine. So mass is something, or you can say the amount of matter. All right, the amount of matter that is contained in a body. All right. Let's say, let me give you the example. This is a bottle. Okay, you can see it is a water bottle. It contains water. All right. Now this water bottle is made by a lot of molecules. All right. Every matter, whatever the matter is, every matter that is made up of molecules. Molecules are tiniest particle which cannot be seen through our naked eyes. All right. They are very tiny particles. Each and every matter are made up of molecules. And you know what? Now, if I have to calculate the mass of this bottle, then the mass of this bottle means the mass of the molecules which are found in the bottle. All right. Since this bottle is a matter, isn't it? This bottle is a matter because it has mass, it occupies space, which is why it is called a matter. So the mass of this bottle means the mass of the molecules which are found within the bottle. So the amount of matter which is contained in a body is called the amount of matter which is contained in a body is called mass. All right. So mass is a constant quantity. That means, all right. So mass does not change with the place. Suppose you are in Kathmandu, and and 1 kg mass equals to 1,000 gram. And when you go to America, then in America 1 kg mass is also equal to 1,000 grams. That means when places are changed, mass does not change. All right. So because of this reason, mass is called the constant quantity. Okay. And usually mass is measured by the device called beam balance. Okay, beam balance or digital balance. All right. So you might know the digital balance or beam balance. So those who have shock. Okay, there may be imbalance while measuring the mass. Okay, so in Nepali it is called tarazu. You might have heard the word tarazu. Okay, नेपालीमा मासलाई तराजु भनिन्छ. So sorry, नेपालीमा चाहिँ मासलाई मेजर गर्ने डिभाइसलाई तराजु भनिन्छ. In Nepali, the device used for measuring mass is called the imbalance or digital balance. All right. Now this is about the mass. So last time we also learned about the derived quantity, isn't it? Now let me share the screen. Okay, let me share the screen, and you look on the screen properly and try to understand. Okay, class 8 physics, and it is measurement. The slide has been made. Okay, the slide has been made by using Google Slide. I hope you can see properly, and it is related to measurement. Okay, now this the unit of speed is called a derived unit. Okay, it is an important question. In examination, the question might be asked in that way. Why the unit of speed is called a derived unit? All right. So you can see that speed that is noted by v. So speed equals to distance traveled by time taken. You can see the formula there. Speed equals to distance traveled by time taken, and the unit of distance travel is the unit of distance or length. That distance means the unit of distance or length, and the time, that is unit of time. We will have to deal with one unit. Okay, so distance means the distance means the unit of distance or length, and upon unit of time. So the unit of distance, you can see here, the unit of distance that is noted. Okay, the unit of distance is meter, so I have written there m, and the unit of time is second, so I have written there yes, isn't it? So we can see the language there. Hence, the unit of speed can be expressed. You can see there the unit of speed. See there, the unit of speed can be expressed in the fundamental units of length and time, that is meter and second. The unit of speed can be expressed in terms of meter and second. Let me bold it here, let me bold it, and let me keep color also. Okay, so that you could understand properly. So you can see that I have highlighted one m and yes has been highlighted there, isn't it? So meter and second makes the speed of unit. That's why meter is one fundamental unit and second is another fundamental unit. So when two or more fundamental units are combined together, it forms derived unit. So since the unit of speed, since the unit of speed has been made from the fundamental unit meter and from the fundamental unit second, which is why the speed of meter is called the unit of speed is called derived unit. All right, so this is the slide. Let me go to the screen again. You might have seen that one. Now let me give you one more example again. Okay, so again you can see there how the question might be asked in this way. How do you prove that the unit of speed is a, so this might be a question. So you can see on the screen properly there, we know that speed, what is the formula to calculate speed? Speed equals to distance. You can let me, speed equals to, see there, speed equals to distance upon time. So distance, that is actually distance that is written, measured in terms of meter, at the meter. Speed equals to distance that is noted by meter upon small, there should be small one. All right, and time that is measured, that is written in terms of second. Yes. Okay, so speed equals to distance upon time, isn't it? All right, now we can see there. Okay, see there. So the unit of distance is meter, that is noted by m, isn't it? Similarly, the unit of time is second, that is noted by s. So you can see there the unit of distance that is measured in terms of the unit of distance is meter, and the unit of time is second, meter upon second. You can see that clearly, right? So that is meter by second. So the unit of speed is made what? Meter and made up of fundamental units, meter and second. So it is a derived unit. So any unit which is made up of two or more fundamental units, any unit which is made up of two or more fundamental unit, it is called a derived unit. So this is how you'll have to do it. All right, so you can see once again there, we know that speed equals to distance upon time, distance upon time taken, distance that is measured in terms of meters, so I've written there m. Similarly, time taken that is measured in terms of second, so I've written there s. The unit of distance is meter, which is noted by m, and the unit of time is second, which is noted by s, that is meter upon second, meter per second. So the unit of speed is made up of fundamental units meter and second, so it is a derived unit. Alright, so any unit which is made by the combination of two or more fundamental units, that is called a derived unit. Okay, students, are you clear about that one? Okay, now let me give you one more example. Okay, how do you prove that the speed, the unit of force is a derived unit? So before that, let me share slide once again. You can see the slide there. Okay, the unit of work is a derived unit. How can you prove that the unit of work is a derived unit? How can you prove that the unit of work is a derived unit? Work means work done. Okay, work is also known as work done. Work or work done is same. You can write the work done, no problem. Okay, the unit of work done is a derived unit. How is that possible? How can you do it? So you can see there, work done can be calculated by the formula force into displacement, or we can say force into distance. Let me write on the screen. Okay, so question might be asking this way: how can you, let me make it a little big, okay? How can you prove that the unit of force? What is unit of force? Actually, it is Newton. Okay, so I'll let me write here. How can you prove that the unit of force, that is Newton, is a derived unit? So this might be a question. Okay, the question might be asked in this way. All right, now how can you prove that the unit of force, that is Newton, is a derived unit? So right here we have, so force, what is the formula to calculate force? Force equals to mass into acceleration. So mass is measured. Okay, anyway, you can. So force equals to mass into acceleration. This is the formula to calculate force. Let me write. Okay, let me make it. So force equals to mass into acceleration. Let me give it proper color. So force equals to mass into acceleration. Okay, force equals to mass into acceleration. Please memorize this formula. All right, and again, so right, equal to mass that is measured in terms of kg. Mass is measured in kg, so you can write here kg into, and what is the unit of acceleration? The unit of acceleration is meter per second square. Meter per second square. So see there, the unit of mass is kg. This is the unit of mass. All right, so let me give it different color. Okay, and the unit of mass is acceleration is meter per second square. All right, this color. So you can see there, one unit is kg, other unit is meter per second square. So what are the fundamental units there? What are the fundamental units there? Can you just guess? The fundamental units are one kg, second one meter, and the last one second, isn't it? So this is one kg is one fundamental unit. This meter is again another fundamental unit. So kg is one fundamental unit. All right, so this is kg. You can see that kg, and meter is another fundamental unit. You can see meter there. Similarly, from second square we can take 1 second. So second is another fundamental unit. So you can see there, kg, meter, and second are fundamental units or not? Kg, meter, and second are called fundamental units, isn't it? That's why a unit of force is made by the three fundamental units: kg, meter, and second, isn't it? So the unit of force, that is Newton. This Newton, you can see the Newton there. This Newton is made by three fundamental units: kg, meter, and second. So, okay, we can write there. Hence, the unit of force, that is Newton, is made of fundamental units kg, meter, and second. Hence, it is a unit. Hence, it is a derived unit. That's why you can see there kg is one fundamental unit, meter is another fundamental unit, and second, that is another fundamental unit. So the unit of force, that is Newton. Newton is made by three fundamental units: kg, meter, and second, which is why it is a derived unit. It is a derived unit. Are you clear? So this is how we prove that Newton is a derived unit, and that is made by the fundamental units kg, meter, and second. Okay. So students, are you clear about that one? Are you clear? Are you clear? Kavya, Smriti, Sambhavi, Ichha Bazagai, Kelvin Sabkota, Abu Sar Bosnet, Abu Sarji, are you clear? Everyone, are you clear or not? I need to, please raise your hand. Okay, if you are clear, please raise your hand so that I could, that's great. Nirvik, you are not clear? Okay, that's great, wonderful. So, okay, Sarina Kafle, are we clear about that one? If you are clear, then please raise your hand. If you are not clear, then again I'm going to give you one more example. Okay, so now let me give you third example. All right, okay, fine, let me give you again third example. Okay, and I hope third example makes you more clear. Okay, let me share the screen once again. Okay, question number 3 example, or we can say example number 3. Okay, let me give you example number 3. Prove that, or you can say, last time I had given you, last time in that slide I give you one table, isn't it? That table you have to, that formula table, please memorize that table. Okay, and that table gives you idea about formula, SI units, and the symbols. Okay, so please memorize that table. Okay, or prove that the unit of pressure. What is the unit of pressure? It is Pascal. The unit of pressure is Pascal, isn't it? Prove that the unit of pressure, that is Pascal, is a derived unit. So this might be another question. All right, so see it clearly there. We know what is the formula to calculate pressure. You should know the formula. Okay, if you don't know the formula, then you cannot solve it. All right, so please read that table. Last time in that previous slide, I had given you one table. So in that table you can find the formula. Okay, so please read all those formulae. All right, now pressure is given by the formula. What is the formula to calculate pressure? It is the formula to calculate pressure that is noted by the capital letter P, okay, pressure that is noted by capital letter P. So pressure equals to force that is noted by F upon area that is noted by capital letter A. So this is the formula to calculate pressure. All right, so pressure equals to force upon area. So again, what is force? Force means what? Force means mass into acceleration. Underline. Okay, and then you can write there mass into acceleration. Mass into acceleration upon area. Okay, so that is the formula. Why? Because you can write here, because force equals to mass into this is volume. In shortcut, let me write. Okay, or you can write here force equals to mass into, okay, shortcut. All right, so this is force equals to mass into acceleration. Please memorize this. Force equals to mass into acceleration, because I have written there force is mass, force equals to mass into acceleration upon area, same area. Now let me perform the calculation there. Okay, It is missing there. Equal to. So what is the unit of mass? The unit of mass is kg into, what is the unit of acceleration? This mass is measured in kg. This is into, the unit of acceleration is meter per second square. Meter per second square. Second square. All right. Into, okay. Upon, let me underline this. Square. Okay. Now, area. What is the unit of area? Meter square. Meter square. This is the unit of area. Meter square. Isn't it? So you can see there. So what are the fundamental units there? You can clearly see the fundamental units there. See kg, the fundamental units are 1 kg, isn't it? And there is meter, 1 meter, and again there is second square, means you can add only 1 second. So the fundamental units are kg, meter, and second. What are the fundamental units which are involved in making the unit of pressure, that is Pascal, kg, meter, and second? So these are the fundamental units. These fundamental units, okay, kg, meter, and second. Or you can clearly see there, kg, meter, and second. These fundamental units, the unit of pressure, that is Pascal. So the fundamental units are kg, meter, and second, isn't it? Hence, now the unit of pressure, that is Pascal, made up of fundamental units like kg, meter, and second. Hence it is a derived unit. So since kg is one fundamental unit, meter is again another fundamental unit, and second is again another fundamental unit. So when two or more fundamental units are combined together and forms another unit, the new unit is known as a derived unit. You can see that derived unit. Let me give another color, this one purple. Anyway, so this is how we do it. Okay, let me go to the screen again. So students, are you clear about that one? Are you crystal clear? Are you clear? If you are unclear, then please raise your hand. Sambabi Baral, are you clear? If you are clear, please raise your hand, okay? Wonderful. Price ka, are you clear? Okay, so, all right, fine. Admin, please, will you switch on? Price ka, please switch on your mic once. Okay, Price ka, are you clear? Are you clear? I cannot hear your sound. Okay. Speak up, please. Speak once again. Are you clear?
Yes, sir.
Okay, that's great, Price. So how do you prove that the unit of speed is a derived unit? Any idea? Please tell me the procedure, because we don't have much time. So anyway, please go fast.
And the formula to calculate the speed is distance upon time, in which
Okay, all right.
distance is meter, whereas the time is second. So the unit of speed is meter per second, and it is
All right.
derived from two fundamental units, which are meter and second. So it is a derived unit.
That's great. Perfect. Wonderful. Okay, Abusan, please switch on your mic. Okay, Price, switch off your mic. Can you hear me?
Yes, sir.
Now tell me, how do you prove that the unit of pressure is a derived unit?
Sir, unit of pressure.
Yes.
Sir, the formula to calculate pressure is force upon area.
Okay, that's great. Go on, please. And what is the unit of force? Or what is the formula to calculate force again?
Sir, force.
Yes. Force is calculated by the formula mass into acceleration, isn't it?
Yes, sir. So,
Did
sir,
you not see properly in the slide earlier? You should have seen it, isn't it?
Yes, sir.
Focus. You will have to focus, otherwise it might be a problem for you. Okay, please focus properly, right?
Yes, sir.
And we can consult the slide again. Okay, anyway. Gaurav, will you please switch on your mic? Abusan, please make your mic off. Gaurav, are you clear?
Yes, sir.
How do you prove that the unit of pressure is a derived unit?
A unit of pressure is a derived unit because pressure formula of pressure is force by area. force is
Okay, all
equal
right.
and force is equal to mass into acceleration by area, and
That's great.
the unit is kg into meter per second square by meter square.
That means
Uh,
the unit of
so
no, no, listen. The unit of mass is kg, right? And mass and the unit of acceleration is meter per second
meter
square,
per second square,
and
and
the unit of area
unit of
is
area
square
is
meter.
meter.
Square meter or meter square. Okay. And from that, what are the fundamental units then?
The fundamental units are kg, meter per second square, and meter square.
And how does it prove that? How does those fundamental units prove that the unit of pressure is a derived unit? How? How can you say that?
Because the
Okay, Calvin. I guess he has internet problem. Okay, Calvin, please. Are you there?
Yes, sir.
Oh yes. Okay, now tell me, how can you prove that the unit of pressure is a derived unit?
So the unit of pressure, which is Pascal, is a derived. We can prove it by the following ways. First of all, the formula of pressure is force divided by area, and
All right, great.
the formula to calculate force is uh, meter into mass into acceleration
All right, great.
divided by area,
Mm-hmm.
and the fundamental unit of mass is kg, whereas the fundamental unit of acceleration is meter per second square, divided by the fundamental unit of area is meter square. So we get kg into meter per second square divided by meter square, and the fundamental units involved here are kg, meter, and second. So uh, since in the unit of pressure, which is Pascal, kg, meter, and second is involved. We can call it as a derived unit.
Very good. Good job. Great. Okay, students, we are almost end of today's classroom. Today's class. So I will post. I'll post one slide in that Google Classroom. Please study that slide. Okay, and remaining shall study in our next class. Okay, and please do not forget to complete your assignment. Okay, all right. And I'll check your assignment too. And those who have not submitted your assignment, I have kept your record. Okay, you might lose practical marks later on. So please make sure about it. Okay, be careful, right? Anyway, so without any further delay, we don't have much time. So have a good day. Stay home. Don't go out. Be safe and respect parents.